The EU-funded Labyrinth project started in 2020 to create and validate new swarm drone applications through research and development of 4D swarm drone trajectory planning algorithms for implementation in ground control stations and new U-space services supporting swarm drone self-guidance to improve safety, efficiency, and sustainability in civil transport. SESAR is the technological pillar of the EU's Single European Sky policy and a key enabler of the European Commission's Sustainable and Smart Mobility Strategy. SESAR called for urgent action on the airspace dimension, in particular, the development of the so-called U-space concept. The Labyrinth project comes to solve part of this problem, designing a new framework and integrating drone operations safely and efficiently at low levels, below 120 meters, in European airspace.
Labyrinth is an European research project under the SESAR initiative. It aims to create a U-space between ground level and 120 meters altitude, so it enables drone swarms to operate automatically. It also enhances security, safety, and efficiency in civilian transportation.
U-space is a recent definition of how the traffic of drones will be managed in Europe. For several reasons, this traffic cannot be done by controllers and has to be automated. And it can be seen like a coordination of services. In the Labyrinth project, we are implementing some of these services, some of the most key services, and we are testing them in real-life use cases. This implementation and test of the services will allow us to detect weaknesses and gaps in the use-space controls and suggest improvements to its definition.
This project has three main aspects from the technical point of view. One of them is the 4D path planning for obtaining the conflicted path planning, the conflicted temporary and spatially. The use of 5G communication to maintain a continuous communication with all of UAVs independently of the distance of the drone to the operator. We don't need to maintain a visual line or a radio link, a direct radio link, because we use the 5G communication. And also we have another strong part that is how to maintain the cybersecurity of the whole system.
So to plan the mission trajectories, we work with a 3D simulated scenario of the environment, which has a 5-meter resolution. The algorithm we are using to plan these trajectories is fast-matching square, which is based on the light propagation phenomenon. This enables us to add a path tunnel level restrictions regarding other vehicle trajectories and obstacles of the environment.
Have built a very robust communication system that enables the dynamic inclusion of different equipments at both the ground control station and the UAVs in order to dynamically react to the conditions of a mission.
During the project, it has been essential to use robust encryption techniques to protect communications between drones and ground stations. Drones must have security measures in place to detect and mitigate denial of service attacks, which could compromise their functionality and performance. For the future, Labyrinth's partners will seek to further research and develop a new model of urban airspace. To this end, solutions such as Labyrinth must succeed based on several aspects: a common regulatory framework, added value for end users, which will promote the acquisition of this type of solution by different customers, business benefits of developing this type of solution, greater commitment to research, and validation of this type of solution.